Okay, this is Algebra 1. Today we're looking at lessons 2.2 and 2.3, addition and subtraction of real numbers. 2.2 begins on 72. We're using number lines and addition rules to add problems. And then when we get to subtraction, we're going to use rules and the subtraction rule to subtract them. Example number 1 says adding three real numbers. When you have -2 plus -7 plus 10, first thing you want to do is add the first two numbers, or the first two when you can associate them in a different way, which we'll look at an example like that in a minute. You begin at -2. It says to add -7. Your negative numbers are on the left side, or they're going infinitely to the left side, so you want to move 7 places to the left. When you do that, you leave off at -9. You can see in this bubble here, -2 plus -7 is -9. Then you want to take -9, the place you are now, and then it says to add 10 to it. Now that's positive. Your positive numbers are on the right-hand side, so you're going to go 10 places to the right. When you go 10 places to the right, you're going to wind up at +1, which is where you end at. So you start at -2, to add -7, move 7 units to the left. To add 10, move 10 units to the right, end at 1. Therefore, the answer, when you put these three together, -2 plus -7 plus 10 is 1. Now, this is one of those things that once you get comfortable doing it, you're not expected to ever write this out, but you need to think this way, especially when you're crossing over 0. Therefore, take 30 seconds and use number lines to solve both of these. I should say to simplify them. Okay, for the first one, it says 7 plus -3. You begin on a number line at 1, 2, 3, 4, 5, 6, 7. That's where you begin. Then it says to add a -3. That means you're going to go this direction. 1, 2, 3 is how a lot of people do it. Or you could just go with the number line 1, 2, 3 to this spot. And that's at that's at 6, 5. That's at the number 4. So 4. -2 plus 8, you begin on the opposite of the last one at -1, 2, 3, 4, 5, 6, 7, 8, -8. It says to add 2. So we're beginning at -8, add 2. Positive numbers are to the right. Once, twice, that's -6 is where you end up. Here are your rules of addition. To add two numbers with the same sign. So you have in positive plus positive or negative plus negative, you add the absolute values. Remember, all absolute values is a distance away from 0. So if we had 2 plus 3, you would add the absolute value of 2, which is 2, and the absolute value of 3, which is 3. It seems ridiculous to do that because you're adding more work to it. But when you talk about negative numbers such as -2 plus -3, you're going to do the same thing. The absolute value is 2 plus the absolute value is 3. So we're going to add those numbers. And then we're going to attach the common sign. So we get to the number 5 for this one. The common sign for both of these is the one they have. That's the same, the common, which is -5. You attach the common sign. There's your example here. -4 plus -5, the absolute value of each is 9. Then step 2 is to attach that common sign, -9. To add two numbers with opposite signs. Now you don't have both of them the same. One's going to be plus or positive, and one's going to be minus or negative. To add those two, subtract the smaller absolute value from the larger absolute value. So your example, 3 plus -9. -9 is a higher absolute value. So -9 minus, there's a subtract part, the absolute value of 3, and you get the number 6. Then the second step is to attach the sign of the larger absolute value. 9 is the farther distance from 0. It's negative. Therefore, 6 is going to be negative. Here are your properties of addition. Commutative property. Think of people who commute to work. They move. So A plus B, A was first, B was second, move and become B plus A. The example 3 plus negative 2, they move and become negative 2 plus 3. There's your commutative property. Associative properties are groupings. Think of way who you associate with or who other people associate with. The way you group three numbers when adding does not change the sum. Remember, 1 plus 2 plus 3 is 6. So is 2 plus 3 plus 1. So is 1 plus 3 plus 2. It does not matter which order you write them in or which grouping you put them in, you're still going to get the same number. Therefore, A plus B first plus C is the same thing as A plus B plus C first. Negative 5 plus 6 plus 2 is the same thing as negative 5 plus 6 plus 2. The difference between these two, the difference between commutative and associative, is commutative, the numbers actually move. Associative, you just add two of them in a different order. This is the commutative property I demonstrated here because I moved the numbers. 1 plus 2 plus 3, had I done this for the first one, 1 plus 2, and then this for the second one, 2 plus 3, then it would have been the associative property. The identity property is when the number does not change. The example, negative 4 plus 0. Its identity was negative 4 to start. It is negative 4 to finish. When you add 0 to it, it does not change. The property of 0 is the one that people get confused with the identity property. When the number becomes 0, that's when it's the property of 0. This is also the inverse property, which we'll look at more as we get into this semester. The sum of the number and its opposite is 0. So a positive A plus a negative A is 0. Positive 5 plus a negative 5 is 0. So those, don't get those two confused. If the identity remains unchanged, A stays A, negative 4 stays negative 4, it's the identity property. If the number becomes 0, it's the property of 0. Here's example number 2. It says finding the sum. 2 plus 3 plus 4 points, 2.3 plus 4.7 plus 1.2. Notice we use the associative property and we associate 2.3 and 4.7 first. The reason we do that is because 7 and 3 give you the number 10 and it eliminates a need for those decimals. 7 and 3 give you 10. You carry a 1. 4 plus 2 plus 1 is going to be 7. So notice putting those two together first gives you the number 7. Then when you add 7 and 1.2, you get 8.2. You look off to the left, it says using the properties of addition can help make computation more efficient. For example, by adding those two, you get a whole number 7. The second one, you do the same thing. Negative 2 and a third, negative 2/3, I'm off today, plus 6 plus 2/3 is equal to negative 2/3 plus 2/3. Notice we use the commutative property. It moved over this time. It's not just the parentheses. Associative and commutative work almost identically. When you have negative 2/3 plus 1/3, they cancel each other out and give you 0. So now you're using the associative property, saying to do this part first, it gives you 0. Then the identity property, this is the property of 0 when you add something to its opposite. And then the identity property, 6 plus 0, its identity it remains unchanged and it says 6. Take about 30 seconds to do these two. Very similar problems. Okay, this first one says negative 0.7 plus 1.9 plus 0.7. You can use the commutative property. Notice these are opposites of each other. And you could say 1.9 plus a negative 0.7 plus 0.7. Then you can use the associative property, which tells you to do these two first. Those are opposites of each other. So the property of 0 would cancel those out and leave you with plus 0 there. 1.9 plus 0 is simply 1.9. For letter B, all you had to use was the associative property. Before you tried to add negative 3 plus 2/3, you could add 2/3 plus 1/3. They have the same bottom number. It's 3. So you add 2 plus 1 and you get 3. We know that that simplifies 3 over 3 to 1. Now we have negative 3 plus 1. You're adding opposite terms. Remember, one's positive and one's negative. So you're adding the absolute values, or you're subtracting the absolute values. The higher one minus the lower one. So negative 3, its absolute value is 3, minus the absolute value of 1 is 1, and you get the number 2. Then it says keep the sign of the larger absolute value. 3 was the bigger number, or the larger absolute value. It was negative, so it's going to be negative 2. You could have used a number line the same way. You could have begun at negative 3 and moved one time to the right. Okay, here's your checkpoint problem. 1.2 plus negative 8 plus 2.8. Notice 2.2 and 0.8 add up to 1.0. So it's better for you to use the commutative property 1.2 plus 2.8 plus negative 8. Because when you associate these two first, you're going to get a whole number out of that. 8 plus 2 is going to be 10. And when you carry it, 2 plus 1 is 2. So 2.0 is the same thing as 2 plus negative 8. Opposite signs. Subtract the higher absolute value. Negative 8 is a higher absolute value. Minus 2 is a lower absolute value. The absolute value of negative 8 is 8. Minus the absolute value of 2 is 2. That gives you 6. And then it says keep the sign of the higher absolute value. It was negative, therefore it's going to be negative 6. 3/4 plus 3 plus negative 3/4. Again, commutative property, 3/4 plus negative 3/4. Because you'll notice those are opposites, plus 3. Associative property, 3/4 plus negative 3/4. Do those two first. It says that's the property of 0 because they cancel each other out. 0 plus 3. And when you add 3 to 0, the identity remains the same. It's the identity property 3. Okay, when we continue on to section 2.3, go ahead and continue there. Begins on page 79 in the text. We're subtracting real numbers using the subtraction rule, and we're subtracting real numbers to solve real life type problems. There's a definition for you first. It says when an expression is written as a sum, the parts that are added are the terms of the expression. The reason you change subtraction to sum or addition is to where we can follow the exact same rules that we just used in section 2.2. A lot of people, before you got to this class, were taught keep, change, and stuff like that. This is what it's talking about. To subtract B from A, add the opposite. There you go. Keep, change, or whatever. Add the opposite. A minus B is the same thing as A plus a negative B. 3 minus 5 is the same thing, 3 plus a negative 5. Now, all we did was took subtraction and we made it into addition, and we're going to follow the same rules. We have opposite signs, so you subtract the absolute values. It's the difference of A and B, so in this case it would be the absolute value of 5 minus the absolute value of 3. The absolute value of 5 is 5 minus the absolute value of 3 is 3. 5 minus 3 is 2, and you keep the larger sign, so you would have gotten negative 2 in that case. Here's example 1. Negative 5 minus 3 minus negative 1 minus 5. We have 4 things. Use the left to right rule. Negative 5 minus 3 is the same thing as plus a negative. Notice from here to here, it became plus a negative. Plus 1, again, plus the opposite. It's not plus a negative. I said that a second ago. It's plus the opposite sign. So we're just creating from subtraction to addition with opposite signs. 5 plus a negative 3, or negative 5 plus a negative 3, same signs. Add the absolute values, 5 and 3, you get 8. Keep the common sign, it becomes negative 8. So now you have negative 8 plus 1, opposite sign, subtract the absolute values, 8 minus 1, you get 7. Keep the common sign, negative 7. So negative 7 plus negative 5, same signs, add the absolute values, 7 and 5, you get 12. Keep the common sign, negative 12. Now, where people get confused with this is they get confused with multiplication and division. When you multiply and divide the same signs, like in this line here, we would have made that into a positive number. In addition and subtraction, it's not. It's the common sign that you keep, and it becomes, or it remains, negative 12. Take 30 seconds and do this one. Okay, let's take a look at this one. It says 10 minus 5 plus 14 minus a negative 18. Remember, with subtraction, you are adding the opposites. So 10, instead of saying minus 5, you're going to say plus a negative 5. It just says plus 14, so we'll leave that one as addition. Instead of saying minus a negative 18, it's going to say plus a positive 18. So now we got rid of all of our subtraction there, and we could follow the same rules as 2.2. 10 plus negative 5, opposite signs, subtract the absolute values. 10 minus 5 is the number 5. 10 is the higher absolute value, it's positive, so 5 is going to be positive. So 5 plus 14 plus 18, okay? We're adding same signs here, 5 plus 14, you add the absolute values, 5 and 14, you get 19, and since they were both positive, it remains positive. And then you bring down your plus 18. Same steps, you add the absolute values, 19 and 18, and you get 37, and they were both positive, so it remains positive. Here's example number 2. Evaluate the terms of an expression, negative 3 minus 8x minus y. Use the subtraction rule. Okay. Rewrite the difference. All of the subtractions, rewrite them as addition. Negative 3, instead of saying minus 8x plus a negative 8x. Instead of saying minus y plus a negative y. Then you could determine what the terms are. Each term is what's being added. One term is negative 3, that's here. The next one is negative 8x, that's here. And the last one is negative y, that's here. All three of those are being added to each other. Okay, take about 10 seconds and find the terms of these two. Okay, it went a little bit longer than 10 seconds, but 3x minus 5. Changed subtraction to addition, 3x plus negative 5. Now they're being added to each other. One term is 3x. The other term is negative 5. Most people don't need to do this, but this is just the way you can see the things that add to each other are terms. Here's the checkpoint. 1 minus 2 minus the negative 3. We're subtracting. Add the opposites. 1 plus negative 2 plus a positive 3. Remember, it's adding the opposite. Plus a positive 3. Opposite signs, subtract the absolute values. Negative 2 minus the absolute value of 1. The absolute value of negative 2 is 2, minus the absolute value of 1 is 1. Keep the one that has the larger sign. It's negative, so it remains negative 1. Plus 3, again, opposite signs, negative 1 and positive 3. Subtract the higher absolute value. 3 is a higher absolute value, minus the absolute value of negative 1. The absolute value is 3 minus the absolute value of 1 is 1. That gives you 2, and 3 was higher, so it's going to remain as positive 2 for that one. The other one says find the terms, negative 8 minus 7x. Negative 8, make it say plus negative 7x. Now you have things that are adding to each other. One term is negative 8. The other one is negative 7x. And then you're going to do the same thing when you're evaluating a function. It says evaluate the function y equals 2x minus 3 for the values negative 2, negative 1, 0, and 1. All you're doing is in place of this part of the function, 2x minus 3, you're plugging in each of those values, negative 2, negative 1, 0, and 1, and you're getting outputs for each of those. You can see that they increase by 2.